Welcome to our ebook keys video on Summary the book, Hands-on Machine Learning with Scikit-Learn, Keras and TensorFlow, Concepts, Tools, and Techniques to Build Intelligent Systems. In this video, we'll provide you with a comprehensive summary of this highly acclaimed book. So, let's dive in. Welcome to an exciting world where data comes alive and algorithms unveil hidden patterns and insights. In today's digital age, machine learning has emerged as a transformative technology with the potential to revolutionize industries and shape the future. In this video, we are thrilled to introduce you to a groundbreaking book that will be your gateway to mastering this transformative field, Hands-on Machine Learning with Scikit-Learn, Keras and TensorFlow, Concepts, Tools, and Techniques to Build Intelligent Systems. Authored by leading experts in the field, this book serves as a comprehensive guide that bridges the gap between theory and practice. Whether you're a curious beginner or an experienced practitioner, this book caters to all levels of expertise, providing a hands-on approach to understanding and implementing machine learning concepts. At its core, this book harnesses the power of popular libraries such as Scikit-Learn, Keras, and TensorFlow, empowering you to build intelligent systems and make accurate predictions. From the fundamentals of data exploration and preprocessing to advanced topics like deep learning and reinforcement learning, each chapter explores key concepts with practical examples and real-world projects. The journey begins with an introduction to machine learning, laying a solid foundation and familiarizing you with the fundamental principles that underpin this field. You'll then delve into setting up your machine learning environment, ensuring you have the necessary tools and software to embark on this transformative journey. Next, you'll explore the power of data manipulation and analysis with pandas and numpy, essential libraries that enable you to uncover insights and make informed decisions. Visualizing and preprocessing your data will become second nature as you unlock the potential of data visualization techniques and gain hands-on experience with feature engineering and transformation. As you progress through the book, you'll dive into regression and regularization techniques, classification algorithms like logistic regression and support vector machines, and the powerful decision trees and random forests. You'll uncover the magic of ensemble methods and gradient boosting, as well as the art of dimensionality reduction through techniques such as PCA and manifold learning. Hands-on Machine Learning with Scikit-Learn, Keras, and TensorFlow is a comprehensive guide that takes readers on a transformative journey through the exciting world of machine learning. From the fundamentals to advanced techniques, this book equips individuals at all skill levels with the tools and knowledge needed to build intelligent systems and unlock the potential of data. Join us as we explore the captivating chapters and embark on a journey of innovation and discovery in the realm of machine learning. Introduction to Machine Learning. In the chapter, Introduction to Machine Learning, readers are introduced to the fascinating world of machine learning. This comprehensive overview covers the applications, algorithms, and terminology used in the field. The chapter establishes a strong foundation by explaining the key concepts, including supervised and unsupervised learning, model training and evaluation, and the components required for a successful machine learning system. Whether you are new to the field or seeking to refresh your knowledge, this chapter will equip you with the necessary understanding to embark on your machine learning journey. Setting up your machine learning environment. Dive into Chapter 2, Setting up your machine learning environment to ensure you have the necessary tools and software installed to start your machine learning journey. It covers the installation of essential tools and libraries, such as Python, Anaconda, and Jupyter Notebook. The chapter guides you through the process of configuring virtual environments, managing package dependencies, and using version control systems. You'll also discover the importance of GPU acceleration for deep learning tasks and learn how to set up GPU support. By the end of this chapter, you'll have a robust and efficient machine learning environment ready to tackle the challenges ahead. Exploring data with pandas and numpy. Dive into Chapter 3, Exploring data with pandas and numpy to learn how to effectively manipulate and analyze data using the powerful libraries of pandas and numpy. Gain insights into data structures, data cleaning, indexing, and other essential techniques for data exploration. It teaches you how to load, inspect, clean, and transform datasets using pandas data frame. You'll explore techniques for indexing, filtering, and aggregating data, as well as handling missing values and outliers. The chapter also covers numpy's multidimensional arrays and demonstrates how to perform mathematical operations and array manipulation. With these foundational skills, you'll be well equipped to explore, pre-process, and prepare your data for machine learning tasks in subsequent chapters. Data visualization and preprocessing. Chapter 4, Data Visualization and Preprocessing, focuses on the crucial steps of visualizing and preprocessing data to gain insights and prepare it for analysis. It introduces popular visualization libraries like Matplotlib and Seaborn, teaching you how to create informative plots, histograms, and scatter plots. The chapter also explores techniques for handling categorical variables, scaling numerical features, and encoding data. You'll learn about feature selection methods, dimensionality reduction techniques like principal component analysis, PCA, and how to handle imbalanced datasets. By mastering data visualization and preprocessing, you'll be able to extract meaningful information and effectively preprocess your data for machine learning tasks. Linear regression and regularization techniques. Continue to Chapter 5, Linear Regression and Regularization Techniques, to grasp the concepts of linear regression and regularization and apply them to solve regression problems. It covers the theory behind ordinary least squares, OLS, regression and demonstrates how to implement it using Scikit-Learn. The chapter then explores regularization techniques like ridge and lasso regression, which help address overfitting and improve model performance. You'll learn how to interpret model coefficients, evaluate model performance using metrics such as R-squared and mean-squared error, and handle categorical features in regression tasks. With the knowledge gained from this chapter, you'll be equipped to build and analyze linear regression models for prediction and inference. Classification with logistic regression and support vector machines. Progress to Chapter 6, Classification with logistic regression and support vector machines, to delve into classification algorithms and their application in solving binary and multi-class classification problems. It begins by explaining logistic regression, a method used to model and predict binary outcomes. You'll learn about the logistic function, training logistic regression models, and interpreting the coefficients. The chapter then introduces support vector machines, SVMs, which can handle both binary and multi-class classification problems. You'll explore linear and nonlinear SVMs, kernel functions, and hyperparameter tuning. By the end of the chapter, you'll understand the principles behind logistic regression and SVMs, enabling you to apply these powerful algorithms to solve classification problems in machine learning. Decision trees and random forests. Explore Chapter 7, Decision Trees and Random Forests, to learn about decision tree algorithms and the powerful ensemble method of random forests. It starts with decision trees, explaining how they make predictions based on hierarchical if-else rules. You'll learn about entropy and information gain for splitting decisions, handling categorical variables, and dealing with overfitting. The chapter then introduces random forests, an ensemble technique that combines multiple decision trees to improve predictive accuracy. You'll explore the concept of bagging, feature importance measures, and hyperparameter tuning for random forests. By the end of this chapter, you'll have a solid understanding of decision trees and random forests, enabling you to apply these techniques to a wide range of machine learning problems. Ensemble methods and gradient boosting. Move on to Chapter 8, Ensemble methods and gradient boosting, to gain insights into ensemble methods such as bagging, boosting, and stacking, and their role in improving model performance. It explores ensemble methods such as bagging and boosting, including algorithms like AdaBoost and gradient boosting. You'll learn how to combine multiple models to make collective predictions and handle diverse data scenarios. The chapter then focuses on gradient boosting, a powerful boosting algorithm known for its ability to build high-performance models. You'll understand the concept of boosting, learn about the gradient descent optimization process, and explore the popular XGBoost library. By mastering ensemble methods and gradient boosting, you'll be equipped to build robust and accurate machine learning models. Dimensionality reduction with PCA and manifold learning. Dive into Chapter 9, Dimensionality reduction with PCA and manifold learning to understand techniques for reducing the dimensionality of your data while preserving meaningful information. It begins with principal component analysis, PCA, a popular linear dimensionality reduction method. You'll learn how to identify the principal components, perform dimensionality reduction, and interpret the results. The chapter then delves into manifold learning algorithms, including TSNE and ISOMAP, which can capture nonlinear relationships in the data. You'll understand the concept of preserving local and global structures and how to apply these techniques to visualize high-dimensional data. By mastering dimensionality reduction, you'll be able to extract meaningful representations from complex datasets and enhance the performance of machine learning models. Clustering techniques. Continue with Chapter 10, Clustering techniques to learn about different clustering algorithms and how they can be used to identify groups or patterns in your data. It introduces popular clustering algorithms like k-means, hierarchical clustering, and DISCAN. You'll learn how to evaluate clustering results, handle categorical variables, and deal with the challenges of clustering high-dimensional data. The chapter also covers advanced topics such as density-based clustering and spectral clustering. You'll understand the trade-offs between different clustering approaches and gain practical insights into applying clustering techniques to real-world datasets. By the end of this chapter, you'll have a solid understanding of clustering methods and be able to identify meaningful patterns and structures in your data. An introduction to neural networks. Explore Chapter 11, An Introduction to Neural Networks to understand the basics of neural networks and their application in machine learning. It introduces the basic components of neural networks, such as neurons, activation functions, and layers. You'll learn about feed-forward neural networks, backpropagation, and gradient descent for training. The chapter also covers topics like regularization techniques, hyperparameter tuning, and model evaluation. Through practical examples and explanations, you'll gain a solid understanding of how neural networks work and their capabilities. This chapter serves as a stepping stone for delving deeper into the exciting world of deep learning and building powerful neural network models. Deep learning with Keras and TensorFlow. Move on to Chapter 12, Deep Learning with Keras and TensorFlow to venture into the exciting world of deep learning and understand how to build and train neural networks using popular libraries like Keras and TensorFlow. It introduces the popular deep learning libraries Keras and TensorFlow, providing hands-on examples and step-by-step instructions. You'll learn how to design deep neural network architectures, configure layers, and tune hyperparameters. The chapter covers essential topics such as convolutional neural networks, CNNs, for image recognition, recurrent neural networks, RNNs, for sequential data, and transfer learning. With the guidance in this chapter, you'll gain the skills necessary to create sophisticated deep learning models and leverage the power of neural networks for various tasks. Convolutional neural networks. Chapter 13, Convolutional Neural Networks, dives into the world of deep learning for computer vision tasks. It focuses on convolutional neural networks, CNNs, a specialized type of neural network for image processing and analysis. You'll learn about the architecture of CNNs, including convolutional layers, pooling layers, and fully connected layers. The chapter covers techniques for preprocessing images, data augmentation, and transfer learning with pre-trained models. Through practical examples and exercises, you'll develop a solid understanding of how CNNs work and how to apply them to tasks such as image classification, object detection, and image generation. This chapter will equip you with the knowledge and skills to tackle complex computer vision problems using CNNs. Recurrent neural networks and sequence models. Continue to Chapter 14, Recurrent neural networks and sequence models to learn about RNNs and how they can be used for tasks involving sequential data, such as natural language processing. It introduces the architecture of RNNs and explains how they can capture temporal dependencies in the data. You'll learn about popular variants of RNNs, such as long short-term memory, LSTM, and gated recurrent unit, GRU, which alleviate the vanishing gradient problem. The chapter covers applications of RNNs, including text generation, sentiment analysis, and machine translation. With hands-on examples and insights into training and fine-tuning RNNs, you'll be well equipped to tackle sequence-based tasks and harness the potential of recurrent neural networks in your projects. Generative models and autoencoders. Explore Chapter 15, Generative Models and Autoencoders, to understand generative modeling techniques and how autoencoders can be used for unsupervised learning. It explores techniques for generating new data samples using models like variational autoencoders, VAEs, and generative adversarial networks, GANs. You'll learn about latent space representation and the process of generating realistic and novel samples from it. The chapter also covers applications such as image synthesis, text generation, and anomaly detection. With practical examples and insights into training and evaluating generative models, you'll gain a solid understanding of how to leverage these techniques for creative applications and advanced data analysis tasks. Reinforcement Learning Basics. Chapter 16, Reinforcement Learning Basics, introduces the fundamentals of reinforcement learning, a branch of machine learning concerned with learning optimal decision-making strategies through interactions with an environment. It covers key concepts such as Markov decision processes, MDPs, policies, rewards, and value functions. You'll learn about different algorithms like Q-learning and policy gradients, as well as exploration-exploitation trade-offs. The chapter also discusses the challenges and considerations in applying reinforcement learning to real-world problems. By understanding the basics of reinforcement learning, you'll be prepared to explore more advanced algorithms and tackle complex decision-making scenarios in subsequent chapters. Advanced Reinforcement Learning Algorithms. Dive into Chapter 17, Advanced Reinforcement Learning Algorithms, to explore advanced techniques and algorithms in reinforcement learning, such as Q-learning and policy gradients. It covers topics such as deep Q networks, DQN, proximal policy optimization, PPO, and Monte Carlo tree search, MCTS. You'll learn about the challenges of function approximation, the role of neural networks in reinforcement learning, and the trade-offs between exploration and exploitation. The chapter also discusses state-of-the-art approaches, including actor-critic methods and model-based reinforcement learning. By mastering these advanced algorithms, you'll be equipped to tackle complex reinforcement learning problems, optimize performance, and achieve state-of-the-art results in a wide range of applications. Natural language processing with deep learning. Continue with Chapter 18, Natural Language Processing with Deep Learning, to understand how deep learning can be applied to tasks in natural language processing, such as sentiment analysis and language generation. It covers topics such as word embeddings, recurrent neural networks, RNNs, and attention mechanisms for language modeling and sentiment analysis. You'll learn about sequence-to-sequence models, language generation, and machine translation using frameworks like TensorFlow and PyTorch. The chapter also discusses advanced NLP tasks, including named entity recognition, sentiment analysis, and text classification. By delving into the intersection of deep learning and NLP, you'll gain the knowledge and skills to process and understand human language effectively using cutting-edge techniques. Deploying machine learning models. Chapter 19, Deploying Machine Learning Models, focuses on the practical aspects of deploying machine learning models into production environments. It covers topics such as model packaging, containerization using Docker, and deploying models to cloud platforms like AWS and Azure. You'll learn about model versioning, monitoring, and performance optimization for production systems. The chapter also addresses scalability, security considerations, and API development for model serving. By understanding the deployment process, you'll be able to effectively transition your trained models from the development stage to real-world applications, ensuring the reliability, efficiency, and scalability of your machine learning solutions. Case studies and real-world applications. Move on to Chapter 20, Case Studies and Real-World Applications to study real-world examples and applications of machine learning in various domains, gaining insights into practical implementation challenges and solutions. It showcases real-world examples and discusses the challenges faced and the solutions implemented in each case study. You'll explore applications such as image recognition, fraud detection, recommendation systems, and healthcare analytics. The chapter provides valuable insights into how machine learning is being used to solve complex problems and improve decision-making in different industries. By studying these case studies, you'll gain inspiration and a deeper understanding of how machine learning can be leveraged to create impactful solutions in the real world. Ethical considerations in machine learning. Chapter number 21, Ethical Considerations in Machine Learning, explores the ethical implications and challenges associated with the use of machine learning algorithms. It discusses topics such as bias, fairness, privacy, and transparency in machine learning models and decision-making processes. You'll learn about the ethical guidelines and frameworks that can help mitigate potential risks and biases. The chapter also addresses the importance of diverse and representative datasets, as well as the responsibility of machine learning practitioners in ensuring ethical practices. By understanding the ethical considerations in machine learning, you'll be equipped to develop and deploy algorithms that uphold ethical standards and promote fairness and accountability. Future directions in machine learning. The final chapter, Future Directions in Machine Learning, provides insights into the emerging trends and advancements shaping the field of machine learning. It explores topics such as deep reinforcement learning, meta-learning, explainable AI, and the integration of machine learning with other domains like robotics and healthcare. The chapter discusses the challenges and opportunities presented by emerging technologies and explores potential applications and breakthroughs on the horizon. By staying informed about the future directions of machine learning, you'll be able to anticipate and adapt to the evolving landscape, unlocking new possibilities and staying at the forefront of innovation in this rapidly evolving field. In conclusion, this book, Hands-on Machine Learning with Scikit-Learn, Keras and TensorFlow, Concepts, Tools, and Techniques to Build Intelligent Systems, is a comprehensive guide that covers the key concepts, tools, and techniques in machine learning. It starts with an introduction to machine learning and guides readers through setting up their machine learning environment. The book then explores data exploration and visualization techniques, linear regression, classification methods, decision trees, ensemble methods, dimensionality reduction, clustering, neural networks, deep learning with Keras and TensorFlow, and various advanced topics such as reinforcement learning and natural language processing. Additionally, it addresses practical aspects like deploying machine learning models and ethical considerations, and provides case studies and insights into real-world applications. With its hands-on approach and practical examples, this book equips readers with the knowledge and skills to build intelligent systems and tackle a wide range of machine learning challenges. Thank you for watching the digest book, Hands-on Machine Learning with Scikit-Learn, Keras and TensorFlow, Concepts, Tools, and Techniques to Build Intelligent Systems. Be sure to subscribe to our channel for more exciting content about the latest in abstracts in the book world. We hope you enjoy learning.